Hello friends, I Dr. Pankaj Kumar Goswami again welcome you all in the machine learning using Python tutorial series. So in the couple of the videos we have already created and we have gone through a number of the libraries working with the Pythons, and that all are modules that can be incorporated easily with your programming. So very easy, just import your specific library in which you are working, utilize its attributes and all its scripts, execute your program, execute your function, and then find out your output in your way. This is the very beautiful thing. So the previous video we had an initialization of Scipy library of Python. Here in this video we are going to see how all these can be really utilized in some practical fields too. So taking more attributes of Scipy library related with the Python. So this is we are just going to do over here. Today we have this target. So well, first of all, I'm just making you clear for those who are watching this video first time that for writing the Python codes we are using a Google Colab platform. So we are using this Google Colab platform. This is an open source platform. We are going to work with it. So we are going to work with the Google Colab, and those are working with their Spider, they are working on the Conda packages they can work upon. This is just only a platform where you can write your codes. We preferred it because it is easily available on internet. So that's why I'm just preferring this Google Colab and opening this one. So if you find any difficulty, you may watch the previous videos so that you will be able to just open up your Google Colab platform. So in this Google Colab platform, I'm just going to start with my file. So well, we have these files stored with us. So we have started working last time scipyexamples.ipynb file, and I'm opening this file again to see more attributes. So here we have our file for what we are working upon. So the previous tutorials we had here. And importantly, just remember about that, just try to connect, you just have a connect option here. Always connect your file with the Google server so that whatever the codes you are running on, that will be compiled over there. So let's start with this. Let's making today's target. How this Scipy can help us to design signal processing. If suppose you are working in the signal processing anyway, and the signal processing is a very common tool, not related with the engineering, not related with specifically science. So wherever you have some attributes of input, there is a chance of a signal. So wherever the signal is there, there is a requirement of the signal processing, and this requirement can easily be executed with the help of the tools of Scipy library. So here we are going to work this right now. So I'm just simply showing you one attribute of Scipy in signal processing. So many attributes are there. So one example I'm just taking for you here. So initializing the same, creating a new code line, and now starting. First of all, because we are working with the data arrays, so it is important always to import numpy. So we are just calling this, importing this numpy as an entity. Then after, because we are working with the Scipy, so we have to call this also. Import Scipy dot signal as signal. So as we are working in the attribute of the signal attribute, so that's why we are just calling this Scipy dot signal as signal. In the form of signal we are just taking. You may have your own short form also, because always we are seeking to find out to plot all these. So it is important to import matplotlib. So here we have this matplotlib.pyplot as plt. So finally I've just called all these library, first importing numpy for the numerical array purpose, Scipy for using all scientific functioning, Matplotlib for just plotting all this. So with the help of all these three libraries, I'm just going to design one signal processing toolbox. Let's see how it is. So first of all, checking whether anything is written wrong or like that, it will show up here. So well, it is properly executed. Coming to the next code line. So here what we have a target. So let's redesign a low pass and band stop filter. A low pass and a band stop filter. That's we have an attribute to go for. So first of all, looking for this, we have to design basically what bandwidth we are looking for. So first of all, we give this value. First of all, choosing this variable v1. Let's say any variable you can change. And using the signal attribute, this is we are having with the help of this Scipy library signal. So here we are just taking the FIR window and creating this FIR window from a certain range. So this will show you. So if suppose you are going for signal FIR windows, so it will tell you what are the cutoff values or what is the basically the width, window type, everything you can just design. So this time I'm just taking a very simple example, designing how many taps you are looking for and what is the cutoff. So this I have just taken only. Designing for the second one, P2. Here I'm just taking the same attribute and under this I'm choosing another one, taking this one 41, and because this time I'm looking, one is I'm just seeking out to band stop and one is the low pass. So for the low pass I have just given an attribute to cutoff, and for the band stop I have to give another attribute to this one. So I'm just taking this one and creating this 0.3, 0.8. So these two I have just created. So let's change the name of this one, B2. Then taking to an example of just creating another variable for the window 1, comma, H1. Signal dot. So here we are just going to have a frequencies, creating this particular filtering option. Frequencies in terms of what? B1, we have taken this variable. So see, if you are going for this one, it will show you the frequency response. How the frequency response can be calculated? It is just giving an output signal dot frequency response of B, whatever the frequency range you have just chosen up. And all these attributes, if you are going to give them more attributes related with the plotting or the graph or the values that will given up. So this compute the frequency response using these kind of a formula. So directly just giving the response. So here we are just taking the window and as well as the system response. So that's why the frequency and H1, it is my system response is taken here. So those are working with the signal processing, they must know about this relationship. But those are not working with this, but they can have an idea if suppose they are looking to design some sort of filter. A filter can be utilized anywhere. I'll show you, I'll help you, I'll make you able to understand where you can utilize and where you can apply your filter and in what cases you will be looking for it. So I'll tell you. Going for this one, another, creating this signal dot frequency response. And here we are just having this B2. Now see here, so we have created basically the two bandwidths we have just created as the B1 and a B2 over which we were working, and the same we have created the two window function for the filter responses. Here we are just giving the responses. Now the next step, just try to execute this whether it has some error or it is working properly. So I'm just checking it by running. No action is out on it, means it's working like. So you want to check your Windows function, you can just print out and you will have large number of set of values. But rather than that, we are going to plot this one. So I'm just creating a new code line to plot this. Plot dot. So this is all attribute you're just going to print out. You want to give your title. So any title you can give up here. You can simply write frequency response. So this is what the title I have just given. Now I'm just going to plot dot. This is command, and what I'm going to plot, I'm going to plot this W1 with respect to creating now the equation using numpy array log 10. So this numpy array is helping us to find out all the respective values. Log 10 np dot absolute of h1. So it will pick up only the absolute values, and you wanted to give this into the form of some color. You can give, I'm just giving it the blue color. Similarly repeating this one, you may copy this easily. You may copy this one and just change the attributes. Instead of this having, you may have now the W2 as you have your H1. Instead of this, you may have absolute of H2. Simply, if you have this blue, you may change your color. This will become the red. Then after, once you have just created, you wanted to give the labels. This is just only a plot attribute, not related with anything like that. So the plot attribute you can give is in your X level. So what is on X level you wanted to give? So X level you are just giving frequency, suppose that frequency. So you have given on X level frequency, you have just given on a Y level amplitude response in dB that has been created. So let's have Y level, and importantly you are just giving amplitude, and amplitude is you are taking as in a dB. This is important. So I have just taken the X level, Y level. You want to show your grade, then we can later on add it on, and let's show the plot. Plot dot show. So here, see, this is just only an attribute of the matplotlib library. So let's check it out. How does it work? So let's run this program and check. That's so nice. So your filter has been designed now. If you see your filter, you have one in the form of the red, which is your band stop filter, and the one which is basically in a blue color is your low pass filter. It is passing on the low values and definitely stopping out all these, giving a negative attributes. So see, let's try to understand this program. And you want to make over this, so you may create your grid to be on. So you have an attribute, simply type plot dot grid and parenthesis. So it will help you to make you understand so where exactly the values lies. So that can be created here. So let's try to understand what exactly we did in this example. So in this we have basically to study about the attribute of SCIY and signal processing. So I have just taken a simple example to create a low pass and a band stop filter that I have just created. So what I need basically, the important part is what, to plotting purpose I need matplotlib library, that I have started working. And the second, I need the SCI pie, and the SCI pie has all these things like looking for Fourier transform, it has FFT tool, looking for the integration, looking for the optimization, looking for the different kind of a mathematical attributes, algorithm, matrix functions, that all attributes are available in the SCI pie. So here among them I have just chosen only the one, which is the SCI pie dot signal. So here it shows, it will give you all the signal attributes. So these are the important part. Let's start it. So we have started with the low pass and the band stop filter designing process. So first of all, I just created the two variables. These variables are creating your bandwidths. So creating a window. So using the signal attributes, it is creating FIR windows starting from these values from the 40, 0.5. It means it is showing you from over which it is going to stop this one. So if you see in your figure, so this is basically the values to be up here, shown up here. So coming up to the next, and this is to be created a window, what kind of amplitudes to be taken up over. After that, it is itself creating this. If you go here and type only the phi window, it will show you all the attributes. So what it can be, simply just go here, you just type FIR win, and if you just create parentheses, it will show you. So it will give you complete detail. The FIR filter design using the Pinto method. This function computes the coefficient of an finite impulse response filter. The filter will have linear phase. It will be a type 1 if it num taps. It is odd type if it is num tap is a even. So here type second filter. So it give you the value of the what is the type of filter and what is the values. So here we have just chosen this filter, and this filter is just giving an output to us, and that has been chosen up here. So if you see, you're typing this, it will show you all the attributes of your FIR filter window. You can change your window, you can create your own window, whatever you're looking for. This is the FIR filter design. So here I've just chosen these values in terms of what is the basically the magnitude, and let's say you can change your cutoff window, finding out like this 0.8. So you will choose changes and the difference up here. So this is one. The second is, it is created with a frequency response. So this is creating a response in terms of the two variables that can be utilized. If you see here, and simply writing up here, it will tell you. So this is giving the compute the frequency response of a digital filter. So using these relationship, it is directly by just putting only the single value, this small command is just giving the frequency response. So those work in this designing of a filter area, they can understand how much easy it has become right now. So here you have chosen what? So we have just this values creating again in terms of V1 and creating the frequency response of this P1. Same, I'm running this one because I have just created a little change. So if you see now, that here we go on for matplotlib, and under plotting this one, what we are plotting, so we are plotting this W1 with respect to what? So this is to be taken the absolute value. Here we are just taking the x-axis for the frequency responses. So W1 is simply representing your frequency. Your frequency response has been created on this one. So this is what the W1 x-axis, and over the y-axis, this has been created using the numpy array. So creating an amplitude 20 log base 10, and value of absolute value is to be taken. If suppose it is a negative, definitely it may create a problem. So the absolute value of the H1. So H1 absolute value, the frequency response has been taken into two aspects. One is the amplitude and second is the frequency. So here it is the frequency, here is the amplitude. So absolute amplitude has been created into dB. So here if you see this line, so this line is only to create your amplitude response in dB. If you don't write like that, you are simply writing, so the result will be bit changed and it will not be shown up in dB like. For your convenience, I'm just simply writing it H1, and let's see what effects come up. this is what. So because the scale has been created into dB, I'm changing this scale to, and for this h2, see here. So this is basically a frequency response in terms of, so this blue and red line simply showing. I'm just removing the one for making you convenient, or just creating a dash or O something. So creating it a dashed line because it is being repeated. So here you see this. So if we are looking to band stop and low pass, so you show here all these blue lines indicating up to a certain range of the frequency it is passed on, then after it is going on off. And simply you're looking to find out, you can create your subplot option also to see this on a different scale too. How you can go for, let's see. For your convenience, let's try to understand the same example onto two different axes. So I'm using another attribute of this one, creating this plot dot subplot. You can also do this, and I have one row, two column, and the plot number 1. So it will show you the first row, 2 column, 1 row, 2 column, and the plot number 1 is here. Simply look, so this will be given in a blue. Looking for this another plot dot subplot, and here I'm looking for 1 row, 2 column, and the indexing is 2, and let's run out. See, so now I have basically the both for 1. You can easily change your like X level and Y level. It's not a big deal, you can easily create at any time. But importantly, if you see in the blue, now you have basically created here the structure in which the low pass filter is being shown. All the low pass signal pulses has been passed out, and here if you see here a particular, it is a band stop. For a particular period of band it is not working. So you can change all these attributes too. You can find out creating this. If suppose I'm just creating rather than 0.8 to 0.4 and just creating this, creating a band a bit wider, you can go for 0.2 to creating this wider or maybe a smaller one. So I'm just creating it 0.2 to 0.5. So you can find out the changes here. Running and executing this one. Similarly here. So wonderfully we have shifted it all. So now see how much easier it has become to create a design of filter in your way. You wanted to show all of them in the dB responses, that can easily be created. If you wanted to show them exactly in the way what is their attributes, so you can easily go for. So those are working in this filter designing option. Like filter designing is important everywhere. Those are working for the microwave theories and microwave technologies, the filter designing is important. Those are working with the image processing, they are the filter required. Those are dealing with the communication field, the filter designing is there. Those are working with the noise and sounds, definitely the filter designing is there. So creation of FIR and IIR filters theories are very same as it is, but here in this, rather than doing lot of calculation, lot of algorithms writing, it is simple to write a simple step script, and that will help you to give the exact attributes and output of this one. So see how much simple it has become right now. Taking another example for you, suppose that number of time it happens we are working with the transformation tools, designing of filters, system design, system responses, then there is a one more important requirement of creation of poles and zeros. So how we can create all these poles and zeros that we can go for easily? Let's find out one simple example here. So simply I'm just designing here one IIR filter. So this particular example will help you in two attributes. One is the designing of IIR filter as well as poles and zeros. So work with the poles and zeros. Simply I have a simple example. Suppose that I have the same attributes of creating this B and A, designing of this one, and I'm looking to find out the poles and zeros of this one. So how can I go for? So one simple attribute you may have like this. Suppose that I'm just designing a filter for having two things. One is the amplitude and another one is for its frequency response. A simple command you can go for IIR signal dot IIR design, and under this you have to check out what exactly the value is looking for. First of all, if you see everything is here, so find out the first values. What is looking for your pass frequency? 100. Then after, what you are looking for the stop frequencies, creating WS. $200. Then what exactly is the value of your G pass? Let's say I have just taken this 2.0. What you are looking for the gross stop values? Let's say 40.0. Then it is analog. Are you looking to design a basically analog? So you have to go for yes. Yeah, it is yes. So you have to write whether it is true or false. True. I'm designing basically analog filter, and that's done. So this is, I have just created a simple IR design. So I'm just have just given all this cutoff frequency, pass frequency, stop frequency, G pass and G stop. That all you know. So those are working with this, they understand what are exactly these values that I have done. Now how can I go for the frequency response? So taking two attributes. One is the W for the frequency and second is for the amplitude. Checking out the frequency response of this one with respect to BA. So now easily we can have this one. So now a filter has been designed. We may find out and checking this by running out while creating new code lines, and I'm just copying simply all the previous data, taking up from here. Copying this one. These are the matplotlib attributes. So I have just taken frequency, amplitude, grid and show here. So now this is available and ready. Let's run out. So well, this is a kind of a grid to be completed, and in this grid there is a requirement to create basically a main function over which we are going to create this one. So same equation, if you wanted to create it into the DB, we have this equation how we can create. So previously we have done this one. You can go easily typing this plot and creating here with respect to what, creating a W you have here, and you have H. So here using this numpy array, log base 10, creating all these arrays values of absolute H, creating all these values absolute H. So here what I'm just going to plot, I'm going to plot this W and absolute value. It means the DB values of your this one. So let's run. Well, it is IR response, it shows so nicely. So it is basically we are just getting impulse response. Now the target is here to go for the poles and zero plots. So we have to call up some function for that. Let's see. So let's create Z for 0, poles with respect to value k, and you have to call this signal dot t transfer function to 0 pole and values k of what? We have just taken b and a here. So what we had just taken on the basis of this one. Again, the attributes are here. I'm just copying few attributes. You can create your names, title and something. So you can go for easily. Plot. Now we are going to plot all this one. This is the matplotlib library function. And under that, what we are going to plot on the first axis, we are going to plot np dot real pole. Then we are going to plot np dot image pole. And to just make it clear how we are going to present this one, you may have your own attribute on which color you're looking for it. So you may have it red, it may be red and taken to be as O. It will be presented as like comping the same line. Copying the same line, and now this time looking to find out the zeros. So instead of this 0, imaginary of 0, and let's just change color, create it to blue and presentation to be X. So now we have poles and zeros in such a way like that. Try to run out. I'm simply not giving any title to it, not giving any X level and Y level. Now you have already learned, you can give this one. Now I'm simply plot dot show and checking it out. Wow, that's so nice. So now easily all the zeros and all the poles are represented here. So if you see here, the zeros are represented with the help of this cross that are being shown up here. You can change anytime in your way. And we have here basically the poles. So how much simple and how much easy it is with the help of this Scipy library. So well guys or girls, basically my target is here to make you able to understand those are working in the signal processing area. They are having a very good chance to really analyze your data, to analyze your basically frequencies and process your signal, and all this will really be useful when you are looking to find out, to apply, to create your own database, to apply these algorithms on some research areas or some project areas. Those are the students and working their project area, they can create a very wonderful projects on that basis. And this analysis will help you to give the manipulation section, and this manipulation will make your device to be learn what to deal and how to deal in a different kind of a situation. So well, I hope so you might be able to learn this Scipy attributes related with the signal processing, designing of IR filter, designing of FIR filter, creation of the poles and zeros plots, and all the other things related with this one. So well, thank you very much. In the next video, we'll be having more interesting facts related with you. Somewhat you're working in some areas and you're finding difficulty, you can easily comment on that comment box. I'll give a video, I'll help you out in such a way. Thank you very much.